Well, my name is José Luis Morales. I'm going to discuss the master's program on data science. At ITAM, we created this program in 2012 with a team and myself. I'm currently the director, and part of a great deal of this presentation has to do with how we built this program, why was it created, and how is it made. The first question is, there are a lot of things more than data here. This is not just the data. This is a very simple representation of data that was created a long time ago. And what is behind data? Useful information, useful knowledge that may be extracted, and that is the basic function of big data. Now, how can we extract useful information? How can we generate useful knowledge, practical knowledge? That is the main question in big data. So then, after saying this, the agenda is why did we create this master's program? Well, due to an important reason. We know that so this storm of data, this hurricane of data is present, but for it to be studied and analyzed in order to obtain useful knowledge, human resources are needed. So the main reason why we created this master's program was the demand of professional resources and also the demand of methodological resources. The problems with big data are not solved or cannot be solved with conventional resources. The conventional resources that statisticians, mathematics, or political science specialists had or have had in the past. After discussing the demand of professional methodological resources, we'll discuss what is being offered in Mexico in this regard. What is the educational, what is being offered in terms of education in Mexico, and then a little about infrastructure at ITAM. What is the infrastructure that will enable us to create a postgraduate program to solve these sort of needs? So if we have organized the demand, if we know what is the methodological demand, that if we recognize that there is no sufficient supply in Mexico and that we have certain resources at ITAM, then it makes sense to create a program to properly meet and satisfy this demand of resources. So we can think, if we have clear objectives for this program, we can find a way to comply with them, and based on what can we comply with them. This is that we need certain profiles from our students. We require a certain profile from our candidate students so that we can attain the objectives we have set for ourselves with this program. So essentially, the presentation follows this order, emphasizing demand, non-satisfied demand in Mexico. So we'll begin by exploring what is demand, what demand is globally. So, for instance, in the United States, we have a couple of links we can explore. Is there an audio system? Is the audio system connected to this? Apparently not. But I will let this play for a couple of minutes. It is very illustrative how in the United States the lack of resources, the lack of human resources to solve this sort of issues is recognized. So at the government level, an initiative was created to tackle at least 7 areas of interest. The first one, the first thing to do is to recognize that big data is a big deal, and it is a big deal in which not sufficient investment has been made. Therefore, it is necessary to invest in 7 or 8 important areas. For example, national security, energy, public health, e-commerce, and invest in such a way that the infrastructure capable of developing the human elements can be made so that these individuals are trained to solve problems in these areas. In a certain sense, this is a call of attention for CONACYT. This was made in 2010. So in 2012, we decided to invest in an area in which there were no resources. The problem is that we had a lot of problems, but not sufficient resources to address them. Let me go back to my talk. What can we find behind big data? There are a lot of problems, there are a lot of applications in different fields, but also there is, this is somewhat glamorous. The people that are against big data believe that this is a bubble that will burst at some time and that it will collapse. However, the people that support big data on the other side of the spectrum believe that big data will solve all problems in the world, that it will make us happier, that it will make us have more resources, and to be able to live quietly at home, being able to solve our problems from the distance. And these are two extreme positions that are not completely true. For example, on big data, not only can we find glamour, there's not only glamour, there is also math involved. So there's big data, but also big math. Behind big data, not only can we find the large problems and hopes for problem solving, there's also math in a lot of it. And math, statistics, and computing are the ingredients that give life to big data in order to solve real problems. So my I can send you my presentation by email, and if you have an opportunity to look at the videos, well, I think that is a very interesting thing to do. So what is the master's program about at ITAM? Well, essentially it is about exploiting data sets at different scales of magnitude. We believe that not only large databases and large data sets fall within the category of big data. There are any number of problems that are not necessarily at the scale of big data, but that are sufficiently challenging and important in order to be addressed. So the main function of the master's program is to exploit. And what do we mean when we say exploit? Well, it means assembling the data, recognizing which is important, clean it up, structuring, using algorithms and databases, but also we need algorithms that are predictive in the sense that they have to be able to predict aspects from data. And when we say useful knowledge, we do not only mean models based on data. In order to explain current situations, we want to use and based on data create models that are capable of predicting. So those that support and those that are against big data, some say, well, what have statisticians been doing in the past 200 years? Well, they have been analyzing data. So big data is not only about analyzing data, it is about analyzing data plus creating models that are predictable. Or are predictive, sorry. So in my opinion, that is the difference between what has been done in statistics and what is being done with big data now. So who produce this data? Well, there are at least two important sectors. On one hand, there is the scientific sector and the technological sector that produce data from sensors and equipment, and that, in a certain sense, are producing data. And these data have to be analyzed and studied. And we wanted to build models based on such data. So on the other hand, there are also the proprietaries of data, and so in a certain regard, these are generating data, but they are the owners of the data, and in that regard, they need to be. It is necessary to take care of the safety of data, and the issue of data safety has been addressed in different during different talks in the seminar. So then, ITAM. As a university, is not either generating or owner of this information, but it is in the field of creating or training the human resources that will address this issue. So our goal is to create experts, people that are prepared and that can address this sort of challenges. So just to give you an idea of the scale of the data that is being handled today, we have this chart. So a lot of the activities are already flowing at the level of peta or hexabytes. Just to give a more solid idea of what these scales mean, we have this relatively old information. For example, Google processes 24 petabytes of data on a daily basis in terms of telecom. AT&T processes 19 petabytes through its networks. Neurology. What is the capacity of the human brain to process information? It is also in the neighborhood of petabytes. And in binary terms, about astrophysics, every day, that scale of information is generated every night. And now business is another manufacturer, so to call it, of data. It has some of the largest databases in the world that have this size. So if these are the problems, if this is the order of magnitude of the data that is being produced in different areas, then what are we doing in Mexico for it in educational terms, in terms of human resource training? Well, who demands or who requires, well, they require professional and well-trained personnel to perform this sort of work. And we have the finance sector, the Mexican Stock Exchange, the public sector. There's also the educational sector, the industrial sector, the tourism sector, and so on. We could spend several minutes just mentioning sectors in which important amounts of information is being generated. For example, in scientific terms, there are institutes that produce large amounts of data. For example, in astronomy and genomics. In genomics, something that is very interesting is that the experiments have already surpassed the capacity of analysis in the past. Doing genomics experiments was extremely expensive, extremely difficult. However, technology to generate this sort of data is extremely inexpensive. So a lot of experiments can take place, but what is important is to know what is happening and how can we understand what is happening without analyzing the data. However, the studies are now less costly, and the problem is that we now need experts to study this data and to obtain information based on that data. And other areas are molecular biology or molecular biochemistry, imaging, and climate change. What is the current supply in Mexico? Before 2012, there was no supply in this field. This storm of data, this landslide of data, this large amount of applications has existed for at least 10 years. However, we do not know how to solve problems in this field. So this is now supplementing the idea of why we created the program. And now, how do we organize, or how can we give a solid basis to this master's program? Well, we believe that there are three fundamental ingredients for this program. And these issues with big data are not issues that can be solved with mathematics alone. These are not problems that can only be solved with statistics or computing. This master's program has a structure that is actually located at the intersection of these disciplines. We consider that the theoretical basis of the master's program is made in this in the area in which these three areas intersect. So what do we have at ITAM? We have infrastructure in the sense of human resources, technical resources. We have individuals that are working at the mathematics department, people that work at the computing department, and also people that work at the statistics department. We also have laboratories, software, and individuals that can help us assemble the program. So without these resources, it is impossible to assemble the program. Now the question is, now that we have these resources, these needs and profiles, then how can we make this program a reality? Evidently, an immediate question that comes to mind is if big data programs will be solved, then they should have large computers. What are the resources they have? Well, we have human resources, we have laboratories, we have software, but we also have useful infrastructure that is outside of ITAM, but that everybody could have. So we do not have the problem of purchasing equipment. We do not have the problem of purchasing licenses, because we can use these resources, Amazon's resources. We can lease machines and time and memory. We do not need to invest in large laboratories. So this side has been essential in making the Masters on Data Science scalable, in the sense of it being able to solve big data problems. So then if we have these resources, all of which are achievable, then what do we need from our candidates? How can we make this program successful? Well, we need ingredients. Our fundamental ingredients are students. What profile will we request from our students? Well, 3 profiles that match the basis. We have the profile we want in terms of statistics, mathematics, and computing. We want well-trained students in statistics, well-trained in math, and well-prepared in computing also. And now these 3 profiles, requesting or demanding these 3 profiles is difficult. How can we meet these 3 profiles? We wanted 2 out of 3. If the students were to have the 3 profiles, then they wouldn't need the master's course. They would be losing their time. So we need at least 2 strong profiles: statistics and math, or math and computing, or statistics and computing. We are aware that there are no majors currently, or where there are no programs that cover these 3 profiles. We have applied mathematics. They know a lot about statistics. They know about math, and they are weak in computing. And we can, however, we can round up their profile in our master's course, and that is the purpose. We also have computing students that are excellent and preparing programs. They know reasonable math, but they're weak in statistics. So we need to improve their profile in statistics as well as and part of that master's program precisely deals with this sort of of students. We need to work with students that know about math, about applied math, basic science, and engineering. People from applied math, from actuaries that need a stronger training in computing and math, and also individuals that are that work at companies that are addressing these sort of problems and that wish to update their knowledge, update their profile, and also be at the level of the problems that now are taking place regarding big data. So in some sense, this boom of big data is comparable to the birth of computing in the 60s and 70s. There are at least 3 streams or 3 paths for professionals working in this field: electronic engineers, mathematicians, and people that started in the area of computing. So big data will be it is nourished by these 3 areas, and therefore it does not have a specific definition. The definition of big data is still to be determined. And now there are individuals that are already working with some of these problems, but they're doing so empirically. And one of the reasons of admitting them into the master's program is to provide them with formal training. We want people to understand what they're doing. If they are using machine learning algorithms, we want them to know what these machine learning algorithms are. We want them to know about complexity. They want them to know about what can be done and what cannot be done with big data, with machine learning, for instance.
Okay, so this is what we want from them. What do we have for them? How can we prepare it? We have a program which is a 1.5 years. It starts in the autumn and is organized in the following way. The first courses are training courses, fundamentals of statistics. We have a data mining and analysis course as well. That's a phase of big data, which is finding patterns. We have a part which is computational statistics. So many statisticians don't have the computer part. They don't have education. They say no. They need to know what Java is. They need to know how to write a program in C. They need to know how to program, basically. So these 3 courses are somewhat superimposed at points. However, it's an articulated whole that functions harmonically. So these courses are connected. They are not isolated. They are, in a certain way, shared. in the sense that there are projects that use information from other courses. So this way of working is, we call it articulate, and they are articulating. So we have new training courses for some called machine learning or other forms of calling it. But we also have the algorithms, the part that supports the previous part. These are general linear models, which you're familiar with. So the first part is about giving the methodology to students who want the grade. So after these 5 courses, there's a seminar with a strange name, but which plays a fundamental part in the seminar. In the program, I mean, it's a seminar which, well, big data is formed by several applications in different areas. New applications, applications that change with time. So what we do in this seminar is about taking experts to a certain area, and the expert provides materials a couple of weeks early. So we have materials, we're forced to handle it, or then we have a seminar which is not passive if students don't sit down to see what's happening and the speaker says a bunch of things that people are not familiar with. In the seminar, the students are completely drenched, we can say, in the subject that will be discussed. So the first part is exposing or presenting, and then the other part, well, is different. Then we have, if this is done every 15 days, we have 2 seminars a month. Then we have other applications for big data. So this seminar has is like a huge window for students. So students don't sit down and just listen. They also need to participate. Second part, an important part of the master's degree is to solve big data issues, and one of the issues is scalability of algorithms. One can do logistical regression in Excel. There's no difficulty, but doing this with millions of variables or millions of data is something completely different. So courses of the second part are intended to give scalability to the methodology in this area. So in particular, the numerical methods and optimization is crucial in this area. Supervised areas, well, they all finish with optimizations issues. So how will we solve this? Well, through conventional methods. At this moment, we have the brute force needs to be substituted by intelligence. So it's crucial that students understand how a machine learned algorithm functions in the context of big data, and this isn't trivial. The reason of this is that you, student, must understand, know, and have the capability of understanding problems, of writing what a possible solution is, and in the last case, write the software associated with this. So just to finish, what are the final objectives of this program? Well, if we want to have these training courses, what can we do with them? Well, the final objective is to develop computational skills in analysis, use of databases at different scales. Databases are not always structured, clean, and the first step is to clean them at least. We want to develop solid techniques for modern training these whole issues about using machine learning statistics which are actually scalable. What does this allow us? Well, to have predictive models, the difference between what was done in the past and what is done now. Another thing we want to develop in students is that they can write their own software. In many of the applications of big data, we have black boxes, so we don't want students to learn to use black boxes. We want them to develop the appropriate software to substitute these black boxes so they can have their own technology. None of these tasks can be done on their own. It's necessary to have a team. It's necessary to have a team that can comprise all the parts of a big data project and to find a solution, and because in a due time, and that this person can work as a team and that they are able to reach a solution. And this means working pair to pair. So this is something we teach at this master's. We try to develop these types of skills, and something else we want is to, well, this knowledge requires maintenance. We need to promote among students the discipline to maintain at the forefront. If a student takes a master in, let's say, year pass and doesn't understand what the good magazines or good journals are, what the right authors are, wrong authors are, they're going to lose their investment in time and money. So a crucial part is teaching students and fostering discipline for being in the state of the art.